Evening, everyone. Who's ready for the end? uh, it's always interesting doing the live stream through YouTube because, like I've said before, there's the delay. So I'll say something and then I've got to wait for the reaction. I've forgotten who posted it, but thank you for posting the script for that as well. Made that very easy. Slow it down. Okay, hang on. Let me see. There we go. So it was on 10 before. That's on 5. I will probably turn it off some point because it's just going to be bouncing all over everything I'm writing. But I'll leave it on as long as I can. Alright. Well, here we are at the end. I mean, really at the end. Everything's due. We're kind of all done. Obviously, a few people, have extensions and things like that. But for most of you, congratulations. You've just reached the end of Programming Fundamentals, your first programming subject. Probably one of your first one of your first subjects at university. Now there's only, 2.5 more years of this. Modified the script to steal the assignment answers. Good luck. Everyone's been doing well with the assignment. You're doing fine. Okay, so as is usual, while we're in the stream testing phase of the stream before the recording proper, let me see what predictions we had for T. I think one of the big things I've learned from this is I need to get a 2-computer setup, get a video capture card so I can run OBS on a separate computer and have it chew up the cycles on that instead of this one. I'll say it again once we have all the, once we're actually recording. So the official due time is in just under 7 hours from now. So it is 6 minutes past, nearly 7 minutes past 5. The final due time for everything, barring those who have an extension and things, some people who've unfortunately been sick and things like that. The official due time is any time tonight before it becomes Saturday. So right up until midnight. I very strongly recommend do not try and really push that because you don't want to, rely on low latency internet connections, especially in Australia. But you have approximately 7 hours to get everything done. Yeah. All right. So let's see what we've got. The predictions for tea. Earl Grey. That is in general my favourite tea. I tend to prefer it in the morning actually. Genmatcha. It's the new one. That one turned out quite nice. That was just a random buy actually. So it's just a tiny little packet. Well, not tiny. It's 100 grams, so it's the same size as your T2 boxes. In a little Asian supermarket across the road at Central Park. So if you like Asian, especially Japanese lollies and things like that and whatnot, if you go through Central Park down into the little pit where there's all those restaurants, in the corner there's an Asian supermarket that has a bunch of stuff. So that one just happened to be there for $4.50, and I went, hey, yeah, why not? Let's try it. Turns out quite good. It's a pretty good Genmocha. What else? Russian Caravan, Sydney breakfast, Singapore breakfast. Or someone still hoping for that? 2 votes for Genmocha. Once again, I've tricked everyone. So this week, I don't know if you can see it on the camera when I hold that up, but I've gone for the cloudy, probably slightly oily chocolate chai oolong from T2. The cloudy oily part is from the chocolate dissolving in it. You can get the essentially the stuff that makes up the cocoa butter. But it smells fantastic. I'm glad Nick is here to bring a certain level of class to the proceedings. Yeah, not only do I pull out the chocolate chai, I spill it all over the desk. There you go, that's better. Okay, let's add the correct answer. There you go. Okay. So, I'll start the recording now and we'll get down to the main matters. Alright, so welcome everyone to the final lecture for 48023 Programming Fundamentals for Autumn 2021. And hopefully for the vast majority of you, your final Programming Fundamentals lecture ever. Of course, those who are, for whatever reason, in the position that they're coming back, you'll be welcome back with open arms and we'll get you through it next time. So no one should be upset having got this far, regardless of the final outcome. But nonetheless, you probably all pretty much know that you've passed by now, those who have, so you should all be pretty comfortable. Okay, so as I mentioned just before hitting the record button, to those who watching the stream or watching the recording of the stream on YouTube, this is being recorded, of course, as you know from the timetable, at about 5 o'clock on Friday afternoon, so you've got just under 7 hours to finish everything. So if you're for some reason watching this at the last minute and you haven't done the assignments, get on with it. You've still got a little bit of time. But the final due time is midnight, so that's any time before it becomes Saturday. But don't mess around with hoping that your internet connection has sufficiently low latency. You know, make sure you get your submissions in as soon as you can, basically. Right. So, as this is the last lecture, we're not really going to learn... Well, we might learn some stuff, but nothing that's going to be assessed, obviously. So what I mainly want to do is obviously answer whatever questions are coming in. But I also want to talk do a little bit of a recap of what we have covered throughout the semester, just to kind of tie things together, because it's easy when you're in the middle of it to forget everything that you've done. You tend to not exactly hyper-focus, but you narrow in on what you have to learn to get you through the material. And if you don't take a moment to step back from it, think about it a bit, and reflect on what you've done, it's easy to forget that you've actually put in, well, it's not easy to forget you've put in quite a lot of effort, but it's easy to forget that you've actually learnt quite a bit. So once you've got your final assignments, submissions in and all that, take a moment to think about where you were at the start of the subject and where you are now. And I think most of you will appreciate there's a pretty significant difference there. So I want to talk about some of the things that we've done there, just to kind of encourage that, and you should all feel proud of yourselves for getting this far. And I also want to talk a bit about what happens after this subject, particularly for those going on to other programming subjects. So obviously this is an introductory subject, so it's not going to teach you everything that you ever need to know about programming, but we have laid down a couple of the key foundations that take us to most of the other places in programming and programming adjacent things. So there's a whole bunch of topics that we've maybe just touched on, or vaguely hinted at, or that I know come after this that you haven't seen at all. So I'd like to talk a bit about that. But first I think I'll go through these questions and make sure there's no really critical ones, because obviously some of you are probably still in the middle of completing a few last things. So I won't devote the entire lecture to just helping that. Ask on the discussion boards. I mean, at some point I'll have to get dinner and things like that, but I'll do my best to answer some questions tonight. But if you're rushing at this point, obviously, one of the key things you should learn is some time management. But we'll do what we can. Anyway. So any specific questions, I'll ask you to post it separately on the discussion board. Alright, so just confirming, if we have green ticks for all the labs, additional and required, as well as the assignment, are we guaranteed to get 100% of the subject? So yes, with a but. So as long as you've done things the right way, yes. So the caveat is, if we find that there has been misconduct or something like that, obviously then there's going to be ongoing issues. But the vast majority of you, I'm sure, did not do that. So barring any weird stuff like that, if you've got all green ticks everywhere, then you've completed, you've 100% of the subject. Then you have to go back and do new subject plus prog1 plus, and do it all again and try and get all the collectibles. So did anyone find any of the hidden stars? Did anyone find the cloud level? So recommendations of books, resources for further studying during the break if we're still not so confident with everything. Yes. So I do have... So I've done a similar thing for programming 1 as well. So let me just... I'll put that up sometime after the lecture. But I'll give roughly the same advice as I did there. The key thing with improving your programming, regardless of how well you did in the subject, so whether you're still a bit hazy about things or not feeling confident with it, or if you aced everything, is practice. So if you're keen for whatever reason, whether you feel it's because you have to or whether you want to, if you're keen on getting good at programming, practice. Again, like I bring this up usually in the first lectures and stuff like that. Programming is a skill. It's not a magic innate ability. It's a thing that you start off knowing absolutely nothing about, and that you practice and you get better at. Same as any other skill. Like if you wanted to learn to draw, you don't just grab a piece of paper and a pencil and go, hey, look, I can draw. Some people have a certain level of innate ability, But even then, they have to go to art classes and learn how to do things properly, and they have to practice, and they have to do thousands upon thousands of drawings. The same with any sport, the same with anything. Programming is just like that. It's all a skill that you can practice. All right. Having said that, there are two broadly useful ways for self-study with programming. Well, I guess three, really. Not all of them are necessarily suitable for every person. People respond differently to them. So you have to find the one that's right for you. And some of them require different levels of interest and ability. So it's not like they're all immediately open to you. So sometimes you have to do a few things first. The first and probably most accessible one is using various online programming sites. So I'll write these down and put them in a post on the discussion board as well, so you don't have to get them down now or anything. But there is Codecademy, HackerRank, Codeforces, the one that I always forget the name of, that have the competitions. But basically they offer you a whole bunch of exercises that are more or less similar to the way the labs are presented in ed. Slightly different setup and everything like that, but basically the same. And whether you're interested in doing, like HackerRank have competitions, the other one that I'm trying to think of, Topcoder, that's it. Topcoder have competitions. Codeforces programs on focuses on competitive programming. Whether you're interested in that level or not, the key thing they provide is a whole bunch of things where you get a problem and you have to solve it by writing a program. So it's just practice, and you do as much of it as you can, and you try different things, try different languages and stuff like that. So JetBrains Academy is also another one. And don't let my particular suggestions limit you. I'm not saying that they are the only ones. They just happen to be the ones that I thought of off the top of my head. So if you find one and it works for you, it's great. It's incredibly hard in this day and age to find bad programming teaching resources. You can find mediocre ones, no problem, but it's very hard to find ones that will teach you the wrong thing. Mainly because with programming, if it's wrong, it probably doesn't actually work. So you kind of have to be a little bit right to begin with to actually get a result out of it. So I definitely encourage the use of those online sites. Again, like I said, not every single one will be perfect for every single person. Like Codecademy takes a more pedagogical approach, like it's about teaching people to program. HackerRank is about sort of, once you kind of know the basics of programming, to refine your skills and kind of show off a bit. But you don't have to engage in that side of it, but it's got less sort of teaching support. But it gives you a lot of practice exercises. So use it for whatever exploit it for the things that it offers you. You don't have to fit into its boxes. For books and things like that, again, any introductory Java programming textbook is going to be absolutely fine. Once again, it's kind of hard to get teaching programming horrendously wrong. It can be mediocre. It can absolutely be mediocre and boring, but it won't be wrong as such. That said, my current favorite ones for Java and like I said, I'll put these up in the discussion board so you don't have to get them all down now. If you're still a little hazy on things, this is going to be terrible with the bouncing thing, but like I said, I'll write them up. If you're still hazy on things, this Head First Java book is really, really good. Like, it's very cheesy. It's very, very 1990s. It includes a lot of Comic Sans, but it is under all that, it is really well done, and it goes through things at a good pace, and it ties a lot of things together really well. It has a vast number of really stupid pictures for no reason. It doesn't go particularly advanced, so like if you've completely aced this subject and you want to push yourself a bit more, maybe that's not the right one. The other one that I recommend in terms of Java basic learning is Herbert Schild's Java: A Beginner's Guide. So this is published by Oracle, in conjunction with McGraw-Hill, but published by Oracle. So Oracle, for better or worse, own Java. So this in some sense is kind of the official beginner's textbook. It existed before Oracle owned Java anyway, so don't be too afraid of that it's been poisoned by Oracle's commercial practices or anything like that. So this one goes a bit further than Head First Java and is a pretty complete guide to Java. The other nice thing about this is it's more up to date. So Head First Java only goes up to Java 5. There's nothing in basic Java that's been different for decades, so that you don't have to worry about. If you want to go a little further, you need a slightly more up-to-date one. So this one covers up to Java 11. So that includes most of the new stuff. So there's kind of a couple of big Java. So there's the first release of Java 1.0, Java 5, Java 8, kind of the three big milestone releases. Everything else in between is relatively incremental. That might change because they're changing the way they develop Java a bit, thanks to the OpenJDK project. But this Java 11 is sufficient for the vast majority of the new features. There's only a couple of extremely new ones which are not covered in here. So, just as an example, however, in this subject, where are we? We've done approximately this much of the textbook. A little bit more actually, because there's a chapter later on that's not included in that. But you can see there's still a reasonable amount to go in this one. So if you've, like I said, if you've aced this subject, this is probably the, and you haven't programmed before, this is probably the better one to get, right? Because it pretty much covers everything in Java. If you basically already know how to program and this subject was a complete breeze, but you want to learn more about Java, then Herbert Schild has another book, which is Java: The Complete Reference. And it basically, so it is less of a textbook for learning and more of a catalog of, this is every single bit of Java. So just as a comparison, like, that's how much, broadly speaking, that's how much we've done of this book. And the other ones would stop at about here. So there's this much more textbook that covers. Another one, so this is another one where you don't want to touch it till you have a bit of experience programming, but I want to get it in your brain for when you are ready for it. But Joshua Bloch's Effective Java. So this current edition covers up to Java 9, which again, once you're past 8, there's not a huge amount of super important things that you have to worry about there. But this has a bunch of basically really intelligent, sensible ways for dealing with common, somewhat advanced problems. So this does not teach you how to program by any means. You need to know how to program in Java to use this. But it gives a bunch of sort of, basically it's a big list of advice and justifications for that advice, and then justifications for when you should ignore that advice. So there's a few things in Java we haven't seen yet that turn up in here as well, so you'd need to know those before you can use it as well. So some of it is very high level stuff, so prefer interfaces to abstract classes, design and document for inheritance or else prohibit it. But it goes through and justifies all these things. Favor composition over inheritance. None of that necessarily has to make sense to you. But basically it does like a little chapter on do this general strategy instead of anything else, and here's why. And it's really, really good. It's a book to live by. If you go into C++ programming, there is an equivalent one for C++. So there is effective C++ and effective modern C++, which do the same thing for that. And effective standard template library. Sorry, one moment, I'll just put these back on the shelf. So those are my 4 main books I would point people at for Java for progressing further. The other thing you can do to progress is look for things that are with a name, something like data structures and or algorithms in Java. So something like this one. So this is not a particular recommendation for this book. This book is fine, but it's not great. I don't know if you can read. I'll hold that up there. So the title is Data Structures and Algorithms in Java. Oh, Data Structures and Abstractions with Java, sorry. So things like that, books of that type, are generally the next step in most of the programming stuff. So once you've learnt how to program pretty effectively in Java, these are the ones that teach you how to build sort of standardized data structures and abstractions and algorithms in Java. Right? So not just learning how the language works, but how to use the language to solve certain types of problems and build certain types of things. So, for example, the assignment, building a linked list, would be a chapter in this. Maybe. Yeah. Well, Java already includes a linked list, so it might leave it out. But that's the kind of thing you get in it. You get, here's how you build something that does a certain job, as opposed to, here's how to make Java do this basic task. So the third thing I recommend for practicing and improving your skills is building a project. So this is one of the ones that is not completely appropriate to everyone. You have to have the motivation and the time, and to some extent you have to have something that you really want to do. But if you have the time and you have something you want to do, try and build an app that does something. Like, try and make something actually useful. Because in doing that, you have a direction that you can follow for something that you want to try and do. So it really focuses and collects together the things you've learned and helps you realize why they're important and why they're useful and why some parts of it shouldn't be used for particular things and stuff like that. I guess a fourth thing as well is competitive programming. So if you do like programming and you don't mind pressure, join the UTS Programming Society. They help run programming competitions and help people get into various types of programming for fun kind of activities. So the ProgSoc is usually pretty good. I basically haven't talked to them all year, unfortunately, but thanks to the pandemic. But they're a good lot to get in with, and they run, apart from competitions, they run like hackathons and things like that, and all the fun things like that. Okay. So we have. Well, so a more specific version of that. So the original question was recommended books and resources for further studying. Again, like I said, I'll post them. And more specifically, suggestions for what to do when you're taking APPS Prog next semester and want to study over the break. So APPS Prog and Prog Fun are basically designed to line up. So there isn't actually a gap between them or anything like that. The biggest gap in going from Prog Fun and APPS Prog is what stuff did you not learn in Prog Fun that you should have, and how much have you forgotten over the break. Alright, so if all you want to do is get yourself ready for APPS Prog, go back and review the Prog Fun material. That's basically it. If you want to go a bit further, that's absolutely fine. Like going further helps, but that's the minimum that you need. Vim! Ugh. Has Nick been lying about me? I'm an Emacs person. And Nick is planning evil questions. Luke is Gradle. I do not. I hate Gradle. I only used it for one thing, couldn't make the damn thing work. If I've done all my required and additional exercises with blah blah blah, should that be enough for a distinction? Probably. You should be able to basically add up the marks yourself as well. I certainly can't do it off the top of my head. But you've got the breakdown of all the components. So if that adds up to 75 or more, then yes, it's enough for a distinction. Can we see some bash skills in action? Ugh. Oh, bounce demo. Done. This is getting very silly. Ooh, can we see some fencing skills? Where am I? Ooh. Yes, but not on the camera. Camera's not good enough to capture it, and I don't have any of my swords with me. They're all in Newcastle. I am unable to hack the Pentagon yet. Will I be able to hack it after applications programming? Maybe. If you want to hack the Pentagon, join the Cybersecurity Society. That's your best bet for that. They'll get you up to that fast. Okay, so let me just check. Just in general, I don't actually have a real problem with Vim. I do happen to use Emacs instead. But for those of you who enjoy starting fights, find out which one the person likes and then say that you think the other one's better. And then if you've got someone who's like, yeah, Vim and Emacs are fine, as someone's done in the chat, bring in Nano or Notepad++ or some other editor that is far less used. Real programmers only use Ed. So there's an editor called Ed. If you think Vim is annoying, I challenge you to use Ed to do anything useful. So let me just scan the live chat to see if there's anything. That's on that one. Any good Python books resources? Oh yeah, so for so if you want to learn Python over your break or just want to start in general learning Python, I found a lot of the web things. So Codecademy and things like that are really good. Python is once you've done a bit of Java, Python's a fairly straightforward language to pick up. It has some nuances underneath that will take a while to understand, but to just get up and running in Python once you've done Java is really straightforward. So you can kind of just dive into it. I've still yet to find a Python book that I really, really like. The O'Reilly book is pretty good, which is just called Learn Python or something like that. Most O'Reilly books are usually pretty good to begin with. But that one's alright. I don't know if I give it the full Luke seal of approval or Luke seal of hubris, to steal a joke. But yeah, for Python, I actually find the web courses are probably a bit better. Because the design of Python is that there's kind of less going on, so you don't have to understand as much of the underlying architecture to just get stuff done. So working through practical examples is a pretty good way to learn Python. Okay, so I think I've covered all the questions there. Again, if you've got questions about your specific assessment things, post them separately on the discussion board. I won't go through that in the lecture. All right, so on to the other bit. So like I said, one of the main things I want to do here is do just a fairly light recap of the stuff that we've covered in the subject, because I think you should do this for every subject you do, is sit down at the end and think about what it is you've actually learned. Put labels, sort of mentally put labels on things. Because often, like I certainly did this as an undergrad, we fail because we're caught up in trying to get through the subject and trying to learn the stuff. We fail to recognize what it is we've learned. So then when someone comes up to you at the end and says, hey, do you know about this thing? You kind of go, I don't know, do I? And then they show you it and you go, oh yeah, no, I did like 6 weeks of that thing. When you sort of deliberately force yourself to catalog what you've learnt, you have that more readily in your brain, and you can see how what you've done relates to other things better. Right? And that's really useful, because then, stuff you've learnt in this, you go, wait a minute, I remember doing that in ProgFun. I know how to do that, so I can apply that here. Or as you go on, I remember doing that in AppsProg, so I can go and use it in this other subject and stuff like that. So I wrote a little list here. So, as you may remember, right back at the start of the subject, I said that programming languages require 3 basic things to work. So they require state, selection, and repetition. So these are kind of abstract ideas for things that programming languages need. So what have we learned that actually fulfills these? So the basic things in Java, we've learned about variables. Doesn't sound very exciting to begin with, but this is a fundamental concept in programming, and understanding how variables work is actually really important. If you go back, this one's a harder one to think of, but if you go back and think of all the mistakes you made in your programs, a tremendous number of them are to do with mishandling variables and not understanding how variables work is a huge source of bugs. So in Java we have primitive variables and we have reference variables, which are objects. We also learnt some more complex ones. So we learnt a bit about arrays. So we know how to use arrays, how to iterate over them, how to store data in them, declare them, all that kind of stuff. And we also learned about types a bit. And in a language like Java, types are really, really important. And in quite a number of languages. So there's been, a long history of, as with everything, completely unnecessary argument over what's the best type of programming language. And one of the big arguments is over what sort of type system you should have. So Java is a strongly statically typed system. So that means that both variables and data have a type. Those types have to match, and those types have to be known at compile time. So something like Python is a dynamically typed language. So it is a weakly dynamically typed language. So in Python, the data has a type, but the variable doesn't. So you can assign any type of data to the same variable. So you can create a variable that is 1 minute an int, and later on is a string. And those types do not have to be known at compile time. They can turn up at runtime. The types still kind of have to work properly, because if you try and do something to a type that doesn't support it, things kind of fall over. But Python doesn't check that before doing it. It tries it, and if it doesn't work, that's your fault. And there's a range of things in between. So this type system argument is one of those things where there isn't, like almost everything in programming computer science, there isn't a single best way to do it. What they are is different tools for effectively completing different jobs. So if you think of, so again, most of you haven't done Python, but if you think of Python as a language for writing short programs to do relatively simple jobs, the type system in Python makes perfect sense, and it's really useful, because if you're writing a 10-line script, you don't want to have to write something like a Java program where you've got to explicitly declare all the types and do all this other fiddling just to make it work. If you're writing a multi-million line program with 100 other people and you're all assigned to different components of it, having a strong static typing system is really, really useful, because it stops idiots breaking things. Right? So it means people can't pass the wrong type of data into a function at all, so it can't fall over from that kind of error. All the errors not all the errors, but once it compiles, a good chunk of your errors then become logic errors, which are ones the compiler can't catch anyway. Whereas in Python, you can get errors that are just sort of typing errors and logic errors. Typing as in the type of the variable, not as in typing on a keyboard. All right. So when you're writing a big, huge program with lots of other people, having that extra verbose, explicit code like Java has is actually quite an advantage. When you're a lone developer and you just want to write a simple script that's going to read something from a file, convert some numbers, and spit it out to another file, Python is perfect. So we've actually learnt quite a bit about state. So it's really easy to say, oh yeah, we just learned about variables. But variables in procedural imperative languages are the key concept. If you understand how they work, you've got a huge chunk of how the program works. So for selection, let me draw some lines between these. So for selection, we saw if-else statements and how to, given a piece of data, construct a condition that allows us to pick between things. And this is our fundamental mechanism in fact, in almost every programming language for making choices, for selecting, for branching, however you want to think of it. Barring languages that are so old that they have just raw go-tos and jumps, an if statement is really, really important fundamental thing. So once you pair that up with your variables, again, you're a long way to being able to write any program you want. We also did technically see switch statements, and there are lessons about it, but we didn't emphasize it too much in this particular subject. I should have left more space for these things. And for repetition, that's our key basic mechanism for repeating the same piece of code, for doing the same job over and over again. So for repetition in Java, we actually have quite a number of basic ways of forming a loop. So in Java, loops are your basic repetition mechanism, and Java is relatively rich in those. So mostly we've concerned ourselves with for loops and while loops, but we also, somewhere in there, are for each loops and do whiles. Again, you don't have to worry too much about those for this subject, but if you want to really reinforce things, you should go back and have a look at those. So together, however, these things that we've got in front of us allow us to write basically any program we want to. So obviously there's some technical details. If we want to write something to the screen, we have to sort of call particular libraries and stuff like that. But for any basic processing problem, this is enough. So with these things that you learnt in roughly the first 6 weeks of the subject, this is enough. Right. Programming languages up till about, I don't know, let's say 1965, this was all they had. They had sometimes more or less fancy versions of these. Technically, a couple of programming languages were super weird. So Lisp is quite old and it does things in a superficially different way. But assembly language C, this is pretty much everything that's in C. Right? There's a couple more things, but not much. Everything else is just kind of icing to make the job a little bit easier. So with that, if you really learn how to do these, you've learned how to program. So I should label this. So that's about half the subject. What else have we learned? So of course Java is an object-oriented language. So we've learnt a bit about object-oriented programming. So it's a class-based one, so we learned about classes, we learned about objects, and how they relate to classes. So these things don't exist in a vacuum, they're all part of the whole system. How's my ridiculous bouncing thing going? Oh yeah, it clears the thing enough. That's and we learnt about inheritance and the pillars of OOP. Right. So again, this is something that when I write it down in four simple, obviously I'm keeping this relatively light and simple, because when I say we learned about classes, we learned about a whole bunch of stuff there. So methods, constructors, reference variables, static things, etc., etc., etc. So there's a whole bunch of detail that goes into this. So I'm trying to keep it as high level as possible. But when you learn kind of what a class is and how you use that to build objects, and then how objects relate to each other and to the classes, and tie that in with encapsulation, abstraction, inheritance, and polymorphism, that is like 90% of object-oriented programming. The rest of it is learning how to do it in a good way. Right? If all you care to learn about is, what is basic object-oriented programming, we've actually pretty much done that. We haven't done it in a huge amount of depth, but we've been around the bases. That's like, obviously there's still a lot to learn, and learning how to use it effectively is the lifelong task of an object-oriented programmer. But just learning what it is and how to basically put things together is something that we've already covered. What else have I got on my list? So, what else have we learned? So we've also learned a bit about problem solving using programming. And to some extent, that is in a way the real goal of the subject, of any programming subject. Because you can learn programming for programming's sake, it's a fun thing to do. But as a tool that you learn to use, it is a thing that solves problems. It's a thing that solves computational problems, which, can be related to the outside world, of course, through various mechanisms. But being able to start with, we need this job to be done, breaking that down into the things that need to be solved, writing the code to put them together, making sure that code works, and then out of that constructing a working system is essentially a summary of the whole point of programming. And in this subject, we've started a little bit on that journey. Obviously, you're not ready to write, well, most of you are not quite ready to write a sort of a management system for an international shipping company, and to make sure that all their ships are as efficiently loaded as possible and are routed properly, and everything flows together. But that's really a matter of scale, not a matter of difference in quality. So you've been doing the same thing, just on small examples. Right? You're just starting at the beginning. Sort of the same way, if someone asks you to draw an apple in an art class, as compared to paint a giant fresco, it's a matter of scale as opposed to any fundamental difference in the ability or the technique, right? You get better at the technique and you get faster and you can imagine it on a bigger scale, but a lot of what you've done in the subject is just a really small scale of what you do in real life with this thing. Another thing I want to emphasize is that we've learnt a bit about debugging, and people often neglect this. Right? People often think of debugging as a thing that you're forced to do when your code doesn't work. And to some extent that's true, of course. But if you learn how to debug properly, that does two things. One, it makes the task of debugging a lot easier. So when you have to do it, you have strategies and tools for doing it. And two, it teaches you a lot about how programs work. So if you know how to debug something, you're thinking of that while you're writing the program. Whether you're doing it consciously or not, that is going through your mind. So if you learn how to debug effectively, it helps you become a better programmer. So looking at another way of thinking of it is looking at how programs go wrong teaches you to build programs that go right. For those who are, doing an engineering degree and doing this subject, or know some people doing engineering, ask the civil engineers, if you know some, about, some of the case studies that they do and what they will do. And not just civil engineers, architects, chemical engineers, lawyers do this a lot, doctors, almost every medical profession. They look at situations where things have gone wrong and practice in identifying what's gone wrong and how to fix the thing that's gone wrong. And that's what debugging is for programming. It is practicing as a skill, that is, not just an act. It is practicing working out where programs have gone wrong, why they've gone wrong, and how to fix them. And if you know how to do that, that helps you avoid doing it in the first place. So one of the things I would like to urge you to do is keep practicing that. So there's actually a number of books about these things. Right. So again, these are ones where I wouldn't say any one of them is like the most amazing book in the world, but there is something to learn in all of them. So like this one is pretty cool, called Find the Bug. Basically, it is a book of a bunch of broken programs. So it's programs with problems in them. So you start with the program, you try and identify what's wrong with it, and then it goes through a rather exhaustive explanation of what the bug or bugs were and how to fix them and why they turn up. That one less so, but I also like this one as well. So Debugging by Thinking. So it's all about sort of planning how you debug stuff and gives you concrete tactics for working out where bugs are and what's causing them and stuff like that. So they're pretty cool. So I just realized something to add to the list. Okay, so that's an incredibly brief summary, and there's some other things, that I haven't mentioned here. But that's kind of everything we've done in this subject. Distressing when you sum it up that well. But an interesting thing to think about is what are the things that we haven't done in this subject? Or a better name, or where to from here? So, like I said, obviously this is an introductory subject, and there's a reason it's an introductory subject. This is meant to come before other subjects that you're going to do. So what are those subjects? Where does this thing lead? So this is what I'm about to write is, in no particular order, a few of the things that we haven't done. Obviously there is an infinite number of things that this subject didn't cover, but these are the ones that this subject leads to. Right. Man, that just went really wrong. More Java. Bunch of stuff there. So I'll just get all these out and then I'll talk about them a bit. Alright. So this is some, not all, of the things that sort of immediately or in maybe one or two steps follow from this subject. So we started talking about object-oriented design. The sort of next step in that is learning some of the principles, but learning design patterns. And this is one of the things you'll see the beginning of in applications programming. So it goes further than AppsProg will go with it, but it is a I've forgotten the number of that subject, but AppsProg is kind of your first step into deeper OO design. So the other thing you see in AppsProg is more Java. Right? So you'll learn some of the things that are not necessarily core Java things, or well, like they're a part of the main library and whatnot, but they're not the first things you need to know. So in particular, you'll learn about lambdas and enums and generics. Maybe streams by now. I don't know if they've included any of that in AppsProg or not. The other thing that learning Java leads to is learning other languages. So if Java is your first programming language, there's basically two ways this goes. Either you really love it and you'll defend it to the death against everyone else, or you absolutely hate it and you're going to jump ship as soon as possible. Of course, I'm very much the what's it called in the Eightfold Way? The middle path kind of person. Java is good for what Java is good for. Other languages are good for what other languages are for. But going through that period of really learning a particular language you like is a really useful and important thing, because learning one language really deeply helps you learn other ones. So Python. Turns up in a lot of the data analytics, AI subjects, in the cybersec subjects, in the quantum subjects for any people who switch to the comp sci degree and do that. Yeah, you specific. Ooh. Why can't I write number 2? You specifically learn C++ in data structures and algorithms. That's 31251. There is a Intro to C subject, which is run by basically by the electrical engineers. So anyone who goes and does any like embedded stuff or mechatronics or robotics, you'll run into that. You'll learn C Sharp if you go and do the .NET ones or any of the games subjects. And maybe some other ones. There's lots of places where you can learn different things. So if you do any of the web subjects, you'll probably learn some JavaScript. Or maybe if you do the Android dev one, Kotlin, or I don't know if the Android dev one is still running at the moment, but there is one that exists. You might learn Swift in the iOS one. There's a bunch of places you can pick it up. And you shouldn't let the subjects rule what languages you learn either. Right? If you're interested in programming, I very, 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 very strongly encourage you to attempt to learn other programming languages. The first programming language you learn is the most difficult. The second is a bit easier. The third onwards get drastically easy. Especially if you stay in the related language pool. So if you learn Java and C, for example, learning C++ is near trivial. Learning C# is near trivial. So if you stay in that kind of Algol family, then things are pretty straightforward. Jumping to weirder ones, so if you jump to Kotlin or Scala or something, not too hard, but it's a bit of a jump. If you jump to Haskell, that's a fairly big jump. But if you learn Java and Haskell, then other languages are all pretty straightforward. Obviously, algorithms and data structures, you're learning data structures and algorithms. And algorithms and data structures are the fundamental programming tools for solving problems. As compared to the fundamental tools for writing programs, that's the programming language. These are the things, once you've learned how to build something in the programming language, these are the things you build. And combining those together is how you solve problems. So you've already started learning a bit of that. So you've learned a couple of sorting algorithms, you've learned a couple of data structures. 31251 builds on that and teaches you a bit more about how to build them, why you build them in certain ways, and most importantly, how to build them relatively efficiently, and how to work out whether an algorithm or a data structure is efficient. For those who are somewhat more mathematically inclined, which it's probably not a lot of you, but those who are out there, I strongly urge you to go and do the mathematics subject discrete maths if you've got the electives, and that will open up the subject theory of computation 41080. So in that you learn about how these computer things, not how they work as such, but how we understand them mathematically. How to model them, how to talk about their limitations, how to talk about what they can do, and importantly, how to talk about what they can do efficiently. So that goes hand in hand with the algorithmic analysis. Because that's about computational complexity, is about how hard is a particular problem. And if you understand how difficult a problem is, that tells you something about how good an algorithm you can write for it is. And will then consequently tell you whether you've written a good algorithm or the best algorithm or a terrible one. So if you learn a bit about that, you have a really good handle, a really good intro to being able to write not just code, but good code. So we've also learned a bit about software design and software engineering, but kind of not really. We've been building small programs. There's a whole bunch of things that come into play when you start building things that are more than one or two classes. Things that are being built by more than one person. Things that are being built by a team to someone else's specification. So all these complicated details transcend programming, and that's what the discipline of software engineering is really about. It's not like, so as a software engineer, obviously you learn to program, but software engineering itself is not about programming. It's about using computers to solve problems, and about how do you marshal your resources and your people to do that. So this is in the software engineering studios, software development studios, and the two software development subjects, and many others, and more. Alright, so that's an ongoing thing, but those are some subjects that specifically follow on in that path. Sorry, let me just explicitly label this as so I don't. So there's a whole bunch of things that you've seen just the very first bits of that are now about to kind of start to open up. So when you move on to these other subjects and go and do other things, remember to think back to Prog Fun and think, well, how did that relate to this? Because eventually there are little bits that are important there. Again, Prog Fun's an introductory subject. There's only so far we go in it, really. But it is the basis of all these things. Oh, people are screaming in the... So... Yes! I'll get to that in a moment. Thank you very much. So what time are we at? Okay, so just to kind of wrap that up there. So like I was saying, this is basically a recap lecture. It's there to remind you what you've done and to remind you that you've done a lot. A lot of you have gone from absolutely no programming knowledge or skill whatsoever to being able to build a linked list. At the moment, when you're embroiled in it, that may not seem like a lot, but that is a big step. And I want to thank you all for coming along on that journey and participating and trying hard and working and doing your best in it. You should be proud of yourself. So, thank you all. And thank you all to those. I got the 100 subscribers. So I got the Programming Fundamentals play button. I believe this is the first one that has ever existed. So I'll display that proudly. So I don't know if you can follow me when it's bouncing around the screen. So I think I'll put it about here. Depends on how big it is. Maybe I can move it a bit closer to the camera. But thank you all. That's much appreciated. And in turn, so it says it will be delivered at a later date. Again, this is not the end of your relationship with me as students as well. I'm always here. You can always come and talk to me. Some of you I'll have again for other subjects. Some of you, I'll just see in the corridor, but, don't be strangers. Finally, one last important thing. One last important thing that I would ask you to do as well is you should have recently received an email about completing the student feedback survey. Please do complete that. Hopefully, it's your first semester of university, so you're not quite jaded about them yet. But those surveys are really, really important to the functioning of the subject. So if you fill them out honestly and sort of in good faith, so to speak, it's a weird term to use, but with constructively, I guess is the way. If you fill those out constructively, they're really useful. So for each subject, you get 2 surveys. They're not particularly long, so it shouldn't take too long to fill out. But they do 2 things. So you've got one for your tutor, so the person that you had in your lab. And in that, you get to give feedback about how well they did, how well prepared they were, and stuff like that. Please be honest in them. The surveys are completely anonymous, and we don't get the results of the surveys until after all your marks are in. So you can never be punished for what you put in that. They are checked by someone else for identifying marks or abusive comments, so that kind of stuff is a bit pointless to put in to begin with, but that stuff won't get through, so there's no way you can get in trouble for filling out these. But having said that, this is a way that tutors, one, get feedback about how well they're doing and how to improve, and 2, we get feedback about how the tutors are doing. So we know if we've employed, this is basically the only sort of concrete way we get to say whether we've employed good tutors or not. Okay. So tutors who do well get the reward of continuing to be employed if they're available. But this is also a way, if a tutor has done badly, we would like to know. Usually that shows up pretty quickly, but I mean, I don't want it to happen, but if it has happened, I would like to know so we can deal with it. Similarly, the other survey is about the subject itself. So you get to give me feedback in that as well as the subject coordinator and lecturer. But the important bit in that one is telling us what went well in the subject and what didn't go well. And hopefully you can do it constructively. You know? So again, please be honest. You'll be completely anonymous in it. So it is sort of, again, the almost the only concrete route we have for finding out what you guys think of the subject in a formal kind of way. Obviously, once I've got my 100 subscribers POG button, then I can just wave that around. That does also affect the future of the subject. So for example, if I had done particularly badly and you say, hey, this lecture was terrible, that would affect my future teaching this subject at least. Right. So this is not just for me, this is for every lecturer. If you like what a lecturer has done in a subject, please fill out the survey and tell them. So it's usually easy to get people to complain in the surveys because when people are angry, they're more motivated. So it's fine that they do that. But what we often miss is the people who are happy with the subject. And that's really important to get across. And I hope those of you who are either angry or happy do fill out the survey. So again, that survey should be in your email. So if you missed it, please check your student email again and fill those out when you can. All right, so let me just one last time go through the questions. Make sure there's nothing important there. Okay. What other subjects do I teach? So for those who are either interested in following me or avoiding me, it's a little hard to say what subjects I teach. So one of the jobs I seem to have in the department is going in and fixing subjects. So when something is not working, they usually move me to that. But having said that, subjects that I have had at least some hand in, 31251 data structures and algorithms. So I designed that from scratch a few years ago, and as far as I know, it's still running basically the way I designed it. I hope to get back to teaching that someday because it's one of my favorite subjects. But I think my lectures are still floating around. But I think that is definitely a really important subject. A lot of you will be forced to do it. It is a hard subject, but is one where if you work, you get a lot out of it. And I think it's really useful. I also designed 41080, Theory of Computation. That is possibly my single favorite subject. It most closely relates to my research area. You have to do discrete maths and AppsProg to be able to do that one. So most of you will do AppsProg, but if you really want to learn about it, but it's quite mathsy, so if you're not mathematically inclined, you probably won't enjoy it all that much. But I designed that one. Obviously Programming 1, which none of you can do, I designed that. I teach this one and will probably be teaching it again next autumn. I have been involved with applications programming, so I used to teach that. That didn't really need a redesign, so it's mostly the same as it was, but it's been run by Angela Hua for quite a while now, so I think she's sticking with that. There is an advanced algorithm subject which will be starting next year, hopefully, all things going well, and that is completely mine. It'll be taught by a mixture of me and some other people, but that belongs to me at the moment until they need me to go do something else. So that's the main ones. No, Raymond's not dead. Raymond just retired. It's not application. So programming fundamentals as it is now is largely designed by Raymond Lister, who is also a fantastic lecturer. But he just retired, so he was at retirement age. So he's enjoying himself up in the Blue Mountains where he lives. Still co-supervise a PhD student with him, so I see him, well, mostly every week. Oh yeah, no, it was a voluntary retirement. He chose that. He didn't get pushed out. Nick, always making lewd jokes in the... See, this is why I fired you. I didn't actually fire Nick. Do I get a raise if the surveys are good? Can we get Nick a promotion? No, I don't get a... Well, I mean, technically, if the results of my surveys are good, they would go into a promotion application, and that's kind of a raise, but academics don't get bonuses or raises. We have fixed salaries. Can we get Nick a promotion? Nick needs to finish his degree. If he'd hurry up and do that, I could get him to do a bunch of stuff, but I mean, he has good excuses for that. That's okay. So once again, so I think I'll shut down the recording in a moment, but just before I do that, again, to everyone watching now or in the future, thank you for paying attention. Thank you for going through this whole thing with us, sticking with it to the end. Thank you for trying. I know programming is definitely a difficult thing to learn, and you should be proud of yourself if you've gotten this far. That's not to say those who didn't get this far shouldn't also be proud of themselves, but definitely if you got this far, you should be proud of yourself. You've made like the first big small step on a path that can open a lot of interesting doors if you're interested in this kind of thing. Programming is a fun and interesting thing to learn, but it's also incredibly useful, and it's going to be absolutely essential very soon. People who can program are the ones who are going to be running almost everything. So you've made a good choice learning to program. All right, so for those who I'm about to basically hang up on by stopping the recording, thank you all. I'll see you soon in other places. All right, and for those in the stream, yeah, exactly, the first pebble of the mountain. First step to Minecraft. Yeah, I should have put that on What Haven't We Done? So that's good. There's only a few questions on the thing. All right. One reminder for those who are watching this as well, I should have put this on the recording. Go and check particularly your Part B, Section B Part 2 and Section B Part 3 ones, that they're still passing all the tests. There was some gaps in the test, which because essentially Nick is more patient than I am, Nick identified. So the tests have been updated. If your code worked to begin with, then it should still work. The key problem with most of them is that people have been using equals equals instead of the equals, so double equal sign, to compare strings when they should be using the dot equals method that comes with string. So if you've got string equals equals other string, go and replace that with string dot equals in parenthesis the other string, and that'll fix most of the problems. Yeah, as Nick posted in the chat there. There is a post on the discussion board as well. So a lot of you will just point you straight at that because it explains the whole thing. So if you haven't read that, go and check your email. I posted it out to everyone. All right. I think that's everything. Yeah, as Amash said, it's the final sponsor time. So I think I should do a semi-real one this time, because Raid Shadow Legends haven't coughed up anything. Thank you to T2 and all the other T companies for giving me enough energy to make it to the end of the week and give what was hopefully a useful set of lectures. It would be even better if they were engaging and entertaining, but useful is more important. Thank you all for coming out. Thank you for participating. It's easy, especially in an online thing like this, to basically be talking to no one, and it's been really useful to have you guys there. Like, it slightly in a slightly odd way, I guess, but knowing that there's people there paying attention is actually really motivating for this. Having just spent a year giving lectures to classes that don't respond to anything. And thank you all for engaging with it, because this is also a subject where it's very easy to get disengaged. So having you guys do stuff helps. I mean, obviously you guys are engaged, but it also helps keep the other students engaged as well, and that's really important for creating kind of a nice community environment. Because again, it's easy to get lost when you're one student among 600, and you guys are a really important part for making that work. So thank you very much for being there and doing that. Can we end the stream just as the face hits the corner? Okay, so I'll hover over the end stream button, and I may suddenly end the stream if it works. Or I may forget to pay attention entirely and it'll just bounce around forever. Yeah, so I think YouTube has worked well for that. If we're still doing streaming, well, we're almost certainly still doing streaming lectures. I think this is a good way to do it. So close. So like I said, my door here is always open. Oh, I think we're about to